Okay, so this video is going to discuss what gravity is and basically how to solve for it. We've talked a lot about gravity in this class, but now we're going to really define it. So if you know gravity, if you hear that term, most people think about, well, that's the force that pulls things to the center of the earth or pulls things down. It's a little bit more than that, though. It is actually a force that attracts any two objects together. So if you have two objects that have mass and energy, there's a force of gravity in between those objects. So Newton said that this force of gravity that attracts any two objects will depend on two things. It's going to depend on their masses and also how far they are from each other. So it's not just what pulls things down. It is the attraction that two objects feel in each other. So if you have Earth and you're looking at a falling object, well, the two objects are Earth and that object, the one that's falling. So it is what pulls us down, but it's a little bit more than that. All right, so Newton's third law says that for every force you have, there is an equal and opposing force. So for every force that you have, there is an equal opposing force. So basically, if you decide to hit a table with your fist, the force that you exert on the table is going to be equal to the force the table exerts back on your hand. So when we're looking at gravity, any two objects that we have exert a force of gravity on each other. So when we're looking at, let's say, the Earth and the Earth pulls on the moon with a force of gravity, and the moon pulls back on the Earth with a force of gravity. Those forces are equal to each other. The force of gravity in between those two objects, in this case the Earth and the moon, are equal to each other. Okay, so our force of gravity is going to be proportional to their masses. Okay, so when I say proportional, what I mean is as one goes up, the other one goes up. So as mass increases, force of gravity increases. And as mass decreases, so does force of gravity. They're proportional to each other. So as mass gets higher, so does the force of gravity. As mass gets lower, the force of gravity also gets lower. Force of gravity is also inversely proportional to the square of the distance between their center of the masses. Well, okay, let's go ahead and define inversely proportional. So that is basically the opposite of proportional. So as your distance increases, force of gravity should decrease. So the further you are from the object, the less force of gravity you will feel. And the reverse would be true. So as distance decreased, you would feel more of a force of gravity. So that's what inversely proportional means. As one goes up, the other one goes down. Now, it also says to the square of the distance between their centers of mass. Okay, so we know what inversely proportional means. Means as one thing goes up, the other one goes down. But we need to know what the square of the distance means. So basically, if you're trying to figure out what factor the force of gravity is going to increase or decrease by, you're going to have to square that number. And let's look at this question right here. So if the two objects are twice as far away from each other, what happened to the gravitational force? Okay, so we know that the radius or the distance rather, increased by a factor of 2. Since that happened, we're further away from the object, so the two objects are far away, or they have more distance in between them. So we know the force of gravity should decrease. So what you will do is you're going to take that number and square it. So 2 times, the distance increased by 2 times, so we're going to square that number, and we get 4. So that means that your force of gravity will decrease by a factor of 4. So let's say that it triples. So the distance between the two objects triples. We're going to take the 3, because it went up by 3, and square it and get 9. Well, that means that my force of gravity will decrease by a factor of 9. And we're going to do several problems that involve this in class. So if you're still a little bit confused, don't worry. We're going to do some example problems, and I think that'll make it a little bit more clear. All right, so we have solved for force of gravity before. Force of gravity is Fg. But we've only solved for it when we are close to the surface of Earth. So when we solve for force of gravity and we're close to the surface of Earth, we're going to take the mass and multiply it by little g, or the acceleration due to gravity. And we have been calculating force of gravity all year, but this one will be a little bit different, because if we're looking at two objects, we're going to look at this equation. So this equation is good for two objects. So you use this when you have two objects. This equation you use when you're trying to find the weight of something near the surface of Earth, or force of gravity near the surface of Earth. All right, so what does all this stuff mean? So we know Fg is force of gravity. Big G is my gravitation constant. This is a number that never changes. You don't have to memorize it. I will give it to you. So it's 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. That is the gravitation constant. You will have two masses because we're going to be looking at two objects. It really doesn't matter which one is 1 or which one is 2. And then you will have the distance between those two centers. So this is not the radius. I know that's a little confusing because it's little r, but it is not the radius. It is the distance in between two centers of mass. So the distance in between the two centers of the objects. Okay, so when we're solving these types of problems, check your units and make sure they all match with the units in the gravitation constant. All right, so let's go ahead and calculate a force of gravity here. So calculate the force of gravity between 2 kilogram students if their centers of mass are 0.95 meters apart. So first of all, we are looking for Fg, force of gravity. I know that I'm not looking at using 9.8 here because I have two objects. So the first object is 75 kilograms. And the second object is also 75 kilograms because it says two 75 kilogram students, so they each have a mass of 75. The distance they are from each other, so in this case little r, is 0.95 meters. All right, so we know that Fg is equal to big G times the mass of the first object times the mass of the second object divided by their distance squared. Okay, so we know what G is. That's 6.67 times 10 to the negative 11th newtons meters squared divided by kilograms squared. All right, so let's just check. Kilograms, kilograms, so they match. And then meters and meters. So I'm fine, I don't have to convert anything. All right, so at this point I'm just plugging it into the formula and solving for force of gravity. Force of gravity is equal to this large number. times my first mass, 75, multiplied by my second mass, divided by my radius squared, 0.95 squared. Okay, so after I plug all this into the calculator, I should get, hopefully your calculator gives it back to you in scientific notation, but you should get 0.000000416. Or you can say 416 times 10 to the negative 7th power. Yes. So hopefully your calculator will just give it back to you in scientific notation, but that's what it is. So it's a very low force of gravity in between the two students. All right, so let's look at a different type of problem here. Okay, so a satellite weighs 9,000 newtons on Earth's surface. How much does it weigh if its mass is tripled and its orbital radius is doubled? All right, so when you're looking at this problem, first of all, you have 9,000 newtons. You have to decide what that is. Okay, so 9,000 newtons is actually the force of gravity. It says it weighs this much. Remember that weight is the same thing as force of gravity. So the force of gravity is equal to 9,000 here. And then we know that the mass goes up by a factor of 3. So the mass is going to increase by a factor of 3. And then the radius is going to double. So if we go back and we look at a few slides ago, go back a few slides, we talked about how mass affects the force of gravity. We said that mass is proportional. So as one goes up, the other one goes up. So we know that. So if the mass is going up by a factor of 3, so should the force of gravity. So I'm going to take my force of gravity and multiply it by 3. And I get 27,000. And this would be the end of the work if the radius did not also double. So this would be the new force if the mass was just tripled and that was it. Okay, so the radius went up by a factor of 2, or the distance. So it's inversely proportional, which means as one goes up, the other one goes down. So since my radius increased, my force should decrease. So I know that that's going to happen. I need to know by what factor. So I actually have to square this number and get 4. So my force of gravity should decrease by a factor of 4. So I'm going to take 27,000 and divide it by 4. And I should get 6,750. This is my new force of gravity. So whenever you're looking at the radius, you have to square that amount, that factor, and then divide it. If it's increasing, you divide it. So if my radius increases, my force of gravity should decrease, so I'm going to divide. If my radius were to decrease, then my force of gravity should go up, and I would multiply it. So let's look at one more question like this. Okay, so I have a gravitational force, F, exists between point objects A and B separated by a distance r. If the mass of A is doubled and the distance r is tripled, what is the new gravitational force between A and B? All right, so I know that my force should increase since my mass is being doubled. So if that was all of it, I would just be multiplying it by 2. But I also know that the distance is tripled. Well, the distance is tripled, and remember, it's inversely proportional to the square of the distance. So I would take 3, square that number, and get 9. So I would divide my force by 9. I would multiply it by 2 and divide it by 9, which is the same thing as saying 2 over 9 multiplied by the force, because I multiplied it by 2 and then I divided it by 9. Alright, so when you're looking at these types of problems, remember that as mass increases, your force should increase. And it will increase by the same factor or decrease by the same factor. The radius, or the distance, if that increases, my force of gravity should decrease, but by a factor that's squared. So you need to take the factor that the radius increased by and square it to get what happens, get the factor of what happens to the force of gravity.